Section 5.1 talks about the rectangular coordinate system and graphs. And you're going to find the first few modules that we go through leading up to section 5.3 really are going to be kind of building the foundation for the rest of the course. So we're going to go straight into our workbook. We're going to go to page 1 and talk about the rectangular coordinate system. When graphing data, there are two types of data associated with each data point. The first value, x, might correspond to the month. So for instance, x equals 1 might correspond to October of 2025, x equals 2 might correspond to November of 2025, and so forth. In fact, the value of x represents the number of months after September 2025 in this instance. The second value, y, might correspond to the number of new homes sold. So when x equals 1, y might be 673,000. When x equals 2, y then may be 611,000, and so forth. It is clumsy to write our data points this way, so we'll introduce a new notation to write a solution to them more compactly. We will write x equals 1 and y equals 673,000 as 1 comma 673,000. X equals 2, y equals 611,000 as 2 comma 611,000, and so forth. This notation is called an ordered pair. We write the numbers in alphabetical order, the value for x first, then the value for y. Since our data has two variables, we need two number lines to represent our answer. The first number line we'll use is for the values of x. We will draw the number horizontally and label it at the x-axis. The second number line we will use is for the y values. It will be drawn vertically in such a way that it will intersect the x-axis at x equals 0 and y equals 0. We'll call this number line the y-axis. We will then overlay a grid system. This is known as a rectangular coordinate system. Notice that the two axes split the grid into 4 sections or quadrants. Starting at the upper left and moving counterclockwise, they are labeled quadrants 1, 2, 3, and 4. So here's my x-axis, here's my y-axis, there's the origin, 0, 0, and here are my quadrants, quadrant 1, 2, 3, and 4. Using our order of pairs and notation, the origin is the point 0, 0. In general, every ordered pair can be represented as a point on a rectangular coordinate system. To plot a point that represents an ordered pair in the coordinate system, we start at the origin. The x value of the ordered pair gives us the x-coordinate of the point we're plotting. If the x value is positive, we move that many units to the right on the x-axis. If it's negative, then we move that many units to the left on the x-axis. The y value of the ordered pair gives us the y-coordinate point we are plotting. So from our current location, if the y value is positive, we move that many units up. If the y value is negative, we move that many units down. Our ending location is the point that represents the ordered pair. So now let's go to work problems 1, 2, and 3. So we're going to skip to the next page. And we're going to go ahead and work out these problems. So first of all, we have some fill in the blank. So here it says the x-axis is the blank axis, so that's the horizontal axis in a rectangle. So it determines if the ordered pair will be located, we'd say left or right from the origin. The y-axis then would be the vertical axis. And the rectangular coordinate system, it determines the ordered pair will be located down or up from the origin. A point in the plane is defined as an ordered pair x, y, such x is determined by its horizontal distance from the origin, and y is determined by the vertical distance from the origin. So we want to determine the location of the following cities as an ordered pair. So if I take a look at London, it's this point here. My x value is negative 6. My y value is 9. So as my ordered pair, this would be a negative 6, comma 9. Always writing this in alphabetical order. Look at Berlin. My x value is 8. My y value is also 8. So this would be 8, comma 8. Looking at Paris, my x value is negative 4. My y value is 4. So it'd be negative 4, comma 4. Looking at Bern, looks like the x value here is 3. Y value is negative 4. For Madrid, my x value is negative 8, and also my y value is negative 8. And then Rome, x value is going to be 7, y value is going to be negative 9. So it should be positive 7, my bad. So again, we're just going through, reading off the coordinates of each of these points. Now let's go backwards. This time, let's say we're given a point and we want to plot each point. So looking at 2, comma 3, that's my point A. So I go over x equals 2, y equals 3. B is negative 4, negative 6, so I go out to x equals negative 4, then y equals negative 6. That's way down here. So that's going to be my point B. Next one is 0, comma 2.5. So x equals 0, y is 2.5. Well, that's halfway between 2 and 3. So I'm going to mark it right about here. Negative 3, 0, x equals negative 3. Don't move any value y, so that's just going to be where my point D is. So C here is on the y-axis, whereas D is on the x-axis. A would be in quadrant 1, and B would be in quadrant 3. So now let's look at 5, negative 2. That's our point here. That's at my point E. And that would be located in the fourth quadrant. 0, 0 is on the origin, so that's right there. 3, negative 5, so x equals 3, y is negative 5, so that's down here in the fourth quadrant. That's my point G. And then h is negative 5, 2. So that'd be in the second quadrant. And so now we got these points plotted. So again, always going to do the x value first, move horizontally from the origin of the x values, and then move vertically using the y values from that point. Let's go take a look at problem number 3. So this time we want to identify the quadrant or axis where the point lies. So I'm looking at this and I want to determine the quadrant or axis that the point's on. So I'm going to be looking at this negative 4, so x is negative 4, y is 1. That's going to be quadrant 2. Negative 3, negative 2, that's here. So that's quadrant 3. Two comma 6, so x equals 2, y is 6. That lands us in quadrant 1. X equals 0, y equals negative 5. That lands is right on the axis, so that's going to be on the y-axis. 3, 0, that would be here. That's going to land us on the x-axis. And then 5, negative 4 is quadrant 4. We have a special name when the point lies on the y-axis. So like this point 0, negative 5 is called the y-intercept. And a point that lies on the x-axis is called the x-intercept. So if we go back to page 2, the x-intercept is the point where the graph intersects the x-axis. The y-coordinate of the x-intercept is always 0. Likewise, the y-intercept is the point where the graph intersects the y-axis. The x-coordinate of the y-intercept is always 0. So whatever intercept you're looking at, it's the opposite coordinate is 0. So let's take a look at this problem. I want to estimate the x and y intercepts. So let's do the x-intercept. So here's where it intersects the x-axis. It's at x equals 3. Now, in ALEKS, you need to label this as 3, 0. So you have to put parentheses 3, 0. And that would be your x-intercept. Your y-intercept's over here on the y-axis. And you got to remember, you got to write this in the correct order. Here, the x value is 0. So my y-intercept would be 0, 3. Let's try number 5. And it looks like we're going to have two x-intercepts, one at negative 2 and 2. Again, I do not want to write negative 2, 2. I need to write these in the proper form. So my first one's going to be negative 2, 0. My second one is going to be positive 2, 0. And then my y-intercept is 0, negative 4. All right, let's turn the page. So to find the x and y-intercept, to find the x-intercept, we're going to substitute 0 for and there should be a space here, for the y value, and solve for x. To find kind of lost the spaces there. The y-intercept, substitute 0 in for the x value and solve for y. Alright, so to get my x-intercept, I'm going to set y equal to 0 and solve. And I'll just abbreviate that. Well, negative 2 times 0 is 0. 4x minus 0 is 4x. And to solve this, I want to divide both sides by 4. That gives me x equals 3. So here we're setting y equals 0 and solving. So my x-intercept would be 3, 0. Now to find the y-intercept, now I'm going to let x be 0. So go back to my equation, replace x by 0. And this time solve for y. That's just 0. 0 minus 2y is negative 2y. We're going to go ahead and divide by negative 2. And that will give us y equals to negative 6. To be 0, negative 6. Always be really careful to list these in alphabetical order. Putting the x-coordinate first, and then putting the y coordinate. It's very important to do that. Otherwise, Alex will stick out his tongue and say you're wrong. All right, let's try his next one. So again, I'm going to go after the x-intercept. Let's set y equals 0. And hope I copy down the correct equation. So it's a negative 3x equals 20. And then we're going to just go ahead and divide by negative 3. And I'm just going to leave that in fractional form as a negative 20 over 3. So when I write my x-intercept, I'm going to write negative 20 over 3, comma 0. Now to get my y-intercept, I'm going to set x equals 0. So just replace x by 0. Negative 3 times 0 is 0. Plus 10y is just 10y on this side. That's equal to 20. And then we need to divide both sides by 10. This is y equals 2. So our y-intercept is the point 0, comma